So welcome. Thank you for coming. So today I'm going to show you Apache Zeppelin, a new Apache project. So let me introduce myself. My name is DyuHai Doan. I'm working as a Cassandra technical advocate for data stacks. So if you have any questions about Apache Cassandra, just ask me. So who is DataStax? Well, we are a commercial company behind Apache Cassandra. So basically, we just propose an enterprise version of Apache Cassandra. So the question is, why am I talking about Zeppelin whereas I'm working for Apache Cassandra? Well, because this project is amazing. What is Apache Zeppelin? So it is a very new project. Who knows about it here? Raise your hand. Okay, only a few people. A very, very new project. It is still incubating. And if you go to their website, they are telling that it is a web-based notebook that let you play with your data in an interactive way. And you can share your documents with other people. And you can use SQL, Scala, and more. So we will check all these assumptions. So first, let's start with a demo. Okay, where is my demo? Okay, here. So I have a Spark Cassandra demo. First, I will download a CSV file from the internet. Okay, so this is a shell script, very easy to understand. This file contains some data about the unemployment rate in the USA since 1941. So let's just have a look at this file. So this is the content of the file. Okay, you have a header and then you have some numbers. And we are interested only by the unemployed percentage. Okay. Then I will create a table in Cassandra to store the data. So this is the table, this is the key space, the schema. I will also create a new index, secondary index that will be released next month to be able to query data on this table. And finally, I will use Spark to read the CSV file. Okay, so I will start by reading this file here. Then split each line by the comma. I filter out the first line because I'm not interested by the header of the CSV. And then for each line, I just save to Cassandra in the table I just create here, okay, US unemployment. And I also register this table as a data frame to be able to use Spark SQL. Okay, so let's run. Okay, now since I have cached all of those data in Spark memory, I can use Spark SQL. For example, to query, give me all the year where the unemployed percentage is bigger than 8%. So here we have some year where there are more than 8% for the unemployment in the USA. You can change the value, for example, 2%. Then you have almost every year since 1941, okay? The same kind of query, I can use plain Cassandra query language to query my data. Since I have created an index on this column, I can use it to query my data, for example, 6%. Okay, fine. So this is a very fast intro to show you what is Apache Zeppelin. In fact, the architecture is like this. So on the left, you have the web frontend, okay, which is made of AngularJS, Twitter Bootstrap, and NVD3, which is a graph library. In the middle, you have Zeppelin. Zeppelin is a web server, okay? you have two endpoints, a REST endpoint and WebSocket for real-time updates. Okay, but Zeppelin is just a container. It doesn't do anything by itself. It is doing some scheduling, orchestrating the query. But most of the work are done here on the right by the interpreters. So from the Zeppelin, you have a Zeppelin engine that will bootstrap a new JVM, and each JVM is running an interpreter. So you have interpreter for Spark here, for Apache Flink, for many projects, and also for Apache Cassandra. Okay. The communication between the Zeppelin server and those different JVM is using the Thrift library, binary protocol, okay, RPC calls. So what can you have with Zeppelin? You can have a front end and a display system for free. You have a very generic backend. You can query with REST API and WebSocket. And you have a pluggable interpreter system we'll show later. Also, a very nice feature, you can schedule the task with a cron system. So let's start presenting Zeppelin layout. So here is the main entry point. You have a notebook. A notebook consists of many notes. This is one note, this is a second note. Okay. Inside a note, you have many paragraphs. This is one paragraph, this is another paragraph, and so on. So each paragraph has an ID here. You can run each paragraph individually. You can configure it. It has a title, so if I click here, show title, I can change its title. Okay. You can reorder each paragraph by moving it up or down. Since Zeppelin is using Twitter Bootstrap grid system, you can change also the width of each paragraph. For example, let's change it to 6. Okay. Now the order paragraph, let's change it to 6 also. They will be reordered automatically, you see. In each paragraph, so let's change it back to 12 so we can see. You have two sections. The source code section here, I can put my source code here. And the rendering section. This is the rendering of my source code. Okay. I can hide it, hide the source code, hide the result, or expand it. Now, from the node level, you can run all the paragraphs in sequential order. It means that the first paragraph will be run first, and then the next one, and then the next one. You can expand on the source code, hide all the source code. You can clear the output. Oh, this one is nice. You can clone the content of your existing node to a new one because you want to modify it, and you don't want to lose the original source code. Okay, new node. So let's go back to the original one. You can export also the content of all these nodes into a JSON file. Okay. And if you want to import it back into Zeppelin, go back to the main menu and click on Import Node. You can import from a local JSON file or from a web URL. So you can share the content of your nodes with your friends. Last but not least, you can schedule the execution of the whole node with a cron syntax. For example, here, I want to execute this shell script every 5 seconds. Okay, so the cron syntax for every 5 seconds is this. So in this shell script, I just display the time. Execute it. Now it is 50 minutes 06 seconds. If I schedule it, This will be updated every 5 seconds. 20, 25, and so on. Okay, just remove it. It means that you can create a pipeline of data processing and schedule it so it can be executed in order every hour, every week, every day, whatever you want. Last but not least, you can choose the type of technology you want to execute, the type of source code. You have seen that we can have markdown rendering. Okay, you can use a shell interpreter, Angular interpreter for HTML code rendering, or you can use just simple Scala code with the Spark interpreter. Now, let's focus into the display system. This is the biggest strength for Zeppelin compared to all the notebook system. Display system. Okay, how can I display my data? Well, you can just print raw text, okay? Raw display. You can have a formatting as a table. So there is a special syntax in Zeppelin. If you want to display your data as a table, like in Excel, here is the syntax. You start with %table. The first line is the header, and then each line is separated by a line return, and each column is separated by a tab. Okay, so if I execute this Scala source code, you will see this. John Doe, each person with their age. Okay. You can also display HTML source code very simply. So just put %HTML and then just put your source code in HTML. Another nice thing is you can also put plain HTML code and then use a Scala function .display to render them. So here you are. So this is just a Twitter Bootstrap alert panel and some input text. Okay. What is more interesting is that you can have nested display. So for example, I want to have some styles in my table. So I just display a table, and inside one cell, I just put some style. For example, here, I put the color as red. So here, you see red color here. Okay. What is interesting is if you are able to format your data as a table, like in Excel, you will have access to the graph system for free. So let's take an example. It is Scala. I have 6 users, their name and their age. Okay, so I do some formatting with Scala, and I use the magic keyword %table to display it. Okay, and now if you can generate this tabular format, then you have access to the graph system for free. Okay, and what is interesting is you can also do a group by with your graph. For example, I want to count people by their age. So just remove group by age and give me the count. So I have 3% which is 27 years old, 2% 32 years old, and only 1% which is 45 years old. Okay, I can have a pie chart, which is a better chart for this. If we look at the data set, okay, this is true. So you have group by for free, and this group by is done on the client side. Okay, it is not done on the server. You can have also dynamic form. Okay, So for example, I want to have some input text to change, well, the value of my display. So there is a special syntax here, $ brackets, the label of your input text, and then a default value. So if I give another title, it will update my display. Okay. It is also possible to have not only just input text, but also drop down. Okay. So the syntax for drop down is this one. So it is a little bit complicated. You need to do some Scala programming. Z.select the label. Okay. So it is here. Z.select the label. Then a sequence of key value. The key is the real value of your choice, and the value is just the label to be displayed on the website. 1, 2, 3. Okay. And now if I select 2, it will be re-rendered, and the selected value is 2. Okay. Last but not least, we have a very interesting feature for managers. Oh. Just remove this one. I want to be able to export this graph, okay? Because this is what I want to show to my manager. I want to be able to export this graph to somewhere else, okay? So let's see how we can do this. Before, I need to show you some display mode. So this is the default display mode with the source code. You can see the source code. You can hide it, but you can still see it. And the result. If you switch to the simple display, you don't see anymore any difference between paragraphs. All the paragraphs are put together. So you have a very fluid flow of processing. Now I have also the report mode. Here you don't see any more the source code. You only see the rendering of your source code. So this is very nice. For example, you want to show your boss this kind of display. The problem with this is your boss can play with your node, and he can switch back to the default mode where he can change your source code. And you don't want him to change your source code. You want him only to see the result. So how can we do? There is a nice feature which we call export as iframe. Oh, it's ugly. This one is ugly. Let's re-render it. So the idea is I want to be able to export the content of my page, my graph, into another web page. So here, just click link this paragraph, and now you have a web link. Okay, you can put inside another web page. So I have done this as an example. I have created from scratch a simple web page, and I just put the URL here, copy paste, into an iframe. Now let's render it. Simple HTTP server. Okay. Now let's go to localhost. This is the page where I export my graph. So you can see that my boss, he cannot change anymore the source code because the source code is not here. He can only see the results. And what is interesting is you can, at real time, change the display. It will be updated here. You see? If I go back to here, update it. But still, he can still play with the filtering, the input text. So if we want to filter out all people which are older than 30 years old, he can play with it. And it still works both ways, you see. So you can compose all your graph into a big web page from monitoring. Nice. Now there's some interesting feature for people who are working with streamings. Because until now, what I have shown you is, okay, I click on a button, it executes some code from the backend, and I have the result back. So request, response, request, response. What's about streaming? Well, it is a new feature that has been implemented very recently. The idea is you just push some source code to the interpreter. For example, a lots of data to process, and as soon as the interpreter has some results, it will send back to the server, back to the front end, but not directly. It will go through the Zeppelin server first. The Zeppelin server will act as a proxy, okay, a web proxy. So let's see some demo of streaming. So here I have a very silly example. 1 to 5. For each, I will sleep for 1 second, and then I print hello. So normally, if I don't have streaming, when I click the button, it will wait 5 seconds on the server side, and then I will see hello 1, hello 2, hello 3, all at once. But now since we have streaming, let's see. 2, 3, 4, 5. Okay. So as soon as the interpreter has a result, it will push back to the front end. So it works for the Spark interpreter. It also works for the shell. This is a shell script, a simple for loop in the shell script. Okay. So the streaming feature is very limited right now. It only works with simple text output. So if I have a text, it can be streamed back to the front end. But if I have a table display like this, it doesn't work. It is not working. So it means that you cannot have a streaming that will just add new lines into your table. This will be an enhancement I will propose later. But for now, the streaming only works with simple text. Now let's focus to the core of Zeppelin, the biggest feature of Zeppelin compared to other notebooks. This is the interpreter system. Okay. As you can see, all the job is done by interpreters because Zeppelin itself is just a proxy. The idea is you input some source code, which is a bunch of raw text. Zeppelin doesn't understand your text. It can be Spark SQL, it can be a shell script, it can be a markdown script. It doesn't matter. Zeppelin doesn't try to understand it. It will just pass the text to the interpreter. The interpreter does his job and then send back to Zeppelin the result. Okay. So by default, Zeppelin has been developed first time with 4 core interpreters. The Spark one with Spark, simple Spark, Spark SQL, and PySpark. The shell interpreter, the markdown, and the Angular interpreter. And then we have a lot of contributors from the community which have developed all of those interpreters. So this list is not comprehensive. There is every day there is a new interpreter being developed for Zeppelin. I have developed the Cassandra interpreter. Someone else has developed Elasticsearch interpreter, Hive interpreter. There is a PostgreSQL interpreter. Let me show you how you can use the interpreter system. So when you have a node like this, if you click on this button, you can choose which interpreter you want to activate or deactivate in your node. Okay. For example, just remove Markdown. I remove it, deactivate it. Now I have a Markdown here, script. If I click on play, error. Well, error because I have deactivated Markdown. Why is it freezing like this? Now if I put back Markdown, okay, Markdown, error, MD interpreter not found. If I put back Markdown, it should work. Okay. So for each paragraph in one node, you can change your backend. You can switch from shell to Markdown to Cassandra to Spark to PostgreSQL to Elasticsearch to whatever you wish. You can also configure your interpreter. If you click on this menu here, for example, for the Spark interpreter, you have many properties. Okay, the master of the Spark here, it is local because I'm running as a local mode for demo. You can change the amount of memory for Spark and so on and so on. So each interpreter may or may not have properties to be configured. Okay. Fine. Now, suppose that you have some technology you want to be able to use with Zeppelin. How can you do? Well, you can just write an interpreter. It is very simple. I will show you. First thing, to be able to write an interpreter, you have to extend this base class from Zeppelin. You need to register it with a static block. Okay. Give it a name, the class of your interpreter, and optionally you can define default properties. Okay. Name of your property, default value, and a description. So what are those properties? If we go back to Zeppelin, those properties are displayed here. You have a default value you can change. If I click on edit, I can change all of those values. Okay. Okay. You have developed your own interpreter. Now you need to register it. So Zeppelin understand that you have it has a new interpreter into the system. So there are two ways to do this. The first way is to edit this file, Zeppelin configuration. Okay. And there is a static enum, okay. Here, Zeppelin interpreters. So you can see there is a long list of all existing interpreter. You can add your own interpreter, for example, hash-based interpreter. Just add it here. It means that the next time you start Zeppelin, your interpreter will be taken into account. It will be available by default. You don't have anything more to do. Or there is another way. If you don't want to change the source code of this configuration, you can do it at runtime. So there is a sample configuration file, Zeppelin site. You copy it and you change these parameters, Zeppelin interpreter. You add your own, the class of your interpreter here. Okay. So two ways to register. Do not forget to update the POM file to expose the source code of your interpreter into the interpreter folder. And of course, do not forget to add your interpreter as a module of Zeppelin. So let me show you how we can write a very simple interpreter, AsciiDoc interpreter. So who knows Markdown here? AsciiDoc, well, it's very similar to Markdown. It is just another syntax to format text. So the idea of my AsciiDoc interpreters is, okay, I receive a block of text. I need to format it and as HTML, and I send it back to the front end. And that's it. Simple, that's simple. So let's see the source code. So this is my AsciiDoc interpreter. Okay, first I need to register it with Zeppelin using the static block here. Okay, I need to extend, of course, the base class interpreter. I need to override open, close. So for open, I will instantiate a new instance of AsciiDoc. Of course, I need to pull a dependency on a Java library, which is AsciiDoc. Close, I will shut down my instance of AsciiDoc. And the main method to implement is interpret. So on interpret, you have the input text is just a parameter, and you have the interpreter context. What I will do is to convert this input text with AsciiDoc. I have an HTML output as a result, and I return it back to Zeppelin. And that's all. 3 lines. Okay? So let's see it in action. Just go back to... So this is AsciiDoc syntax. So let's check that we have enabled AsciiDoc here. Okay, I have enabled it. AsciiDoc. Copy paste. And then click on play. And here you are. You have a rendering using the AsciiDoc. Okay. So of course this is a very, very, very simple example. You can build something much more complex than this. So now let me show you something much more complex than this. For example, I developed the Cassandra interpreter. The problem with Cassandra is you can have many statements like select and then insert and then delete and then another select. In the same paragraph, you can put many statements. So the idea of this interpreter is, first I need to split all those statements, and for each statement I will call my Cassandra cluster, execute them, and return back the result. Okay. Because I am controlling the formatting, the parsing of the input text, in fact I can create virtually any new commands. For example, with my interpreter, I am able to interpret the basic native Cassandra query language, select, insert, and so on. But I also create new commands which does not exist in Cassandra. For example, describe table. Everyone knows about describe table in Oracle, in SQL. Okay, so I create this new command which does not exist in the native query language to be able to display the structure of a table. I create describe key space. I create a help command. So let's see it in action. So here, if I put help, for example, I want to be able to know what I can do with Cassandra because I'm a beginner. Okay, here, what I have as a result is, well, a help menu, interactive menu with many chapters. I can expand, I can close. Okay. So it is just plain HTML5 content. So how can I do that? Well, very simple. From the server side, I am just using HTML template. Where are they? Here. For example, here you can see from the server I have some Scala HTML template, and at runtime, if people type the correct command, I can render this template and push it back to the front end. Okay, and of course I need to parse all the commands. So to be able to parse all the commands, I am using some regular expression. And there is something called Scala combinator parser. So it means that you can define your own grammar. It is like AntLR grammar. You define your own grammar, and then you let Scala do all the parsing for you for free. Okay. So this is a very complex interpreter where you can, well, you can invent new commands, you can do your own formatting. For each interpreter, you have their documentation online, so you can go on the zeppelin.incubator.apache.org, and there you have their official documentation. The future. So right now, the project is still incubating. It is not an official top-level Apache project. What Zeppelin community wants to do is to provide enterprise features. Authentication, it is very important. I don't want to deploy Zeppelin in production if I don't have security. So we have integration with Apache Zero, and there's ongoing work with not authorization. Okay, multi-tenancy also. Usability. Right now, I can have a table with many graph options, well, few graph options. I want to be able to export the content of a table as a CSV or as a PDF. So there are ongoing pull requests, table pagination, pluggable. I want to be able to provide my own graph system, because if you look back into Zeppelin display system, here we are. There are only 1, 2, 3, 4, 5. Okay, 5 types of graph. Not this one. This one is better. 5 types of graph: bar chart, pie chart, this one, and this one, and that's all. What if I want some different chart? For example, a geo chart. Right now, I need to manually code it with JavaScript. You can do it, but it's not very user-friendly. The idea for the future is to be able to propose pluggable visualization. Okay, people can choose their own visualization. And of course, more interpreters. And we depend on the community. So if you find that there's some missing interpreter, for example, I don't know, for whatever you want, new technology, just write your own and submit a pull request. Okay. Question? No question? Yes.
So when you want to do more CSS styling, but you only return a single stream, you have to inline all the CSS?
Yes, right now there is no, for example, well, you can use existing styling from Twitter Bootstrap, okay? Because it's already loaded by in the index.html file. But if you want to have your own CSS file, what you can do, of course, is to hack. For example, let me show you. Angular. Here you can put a script. You can put a link to your CSS file, and of course, you need to give either a file which exists on internet, you know, using CDN, or a file which exists on your file system. So you can at runtime add any. For example, here I'm doing a div, just plain HTML code. Here you are. So it means that now if you need to have a special graph, you can just import, download a JavaScript library somewhere, and then use it directly. It's still possible. Other question? Yes.
You said that for streaming only text is available right now. What do you think when will it be possible to append new lines to a table?
Just create a pull request. I don't know. In fact, I have watched of the current implementation of streaming, so it's a little bit complicated. If we want to have streaming that append new lines to a table, we need to modify not only the backend, but also the JavaScript source code for the front end to be able to. I don't think it is. I don't think it is complicated, because in fact to be able to display a table, it is a for loop in with AngularJS. So it is very simple. You just modify the list in AngularJS and it will be updated. Yeah, but it needs to be done by someone. So if I have some free time, I will do it. It's on my to-do list. But right now I have a bunch of new pull requests. Other question? Okay, fine. Thank you.